Hello everyone, welcome to my programming club. Today we will be solving another daily Leetcode problem, and the problem's name is time needed to buy tickets. Okay, so the problem statement goes like this: there are n people in a line, standing in a line to buy tickets. Okay, and the very first person, which is the 0th person, so people are numbered from 0 to the n minus 1th person. Okay, so 0th person is in the front of the line and n minus 1th person in the back of the line. So okay, so the situation is like this. This is the, let's say, ticket counter. Okay, and then there are some people standing in queue to buy tickets. Okay, and this is the 0th person, first person, second person, and let's say this is the n minus 1th person. Okay, in total how many number of people are there? Let's say persons, n people. Okay, so they now coming to the problem statement, back to the problem statement and reading it further. You are given a 0 indexed integer array tickets, okay, of length n, where the number of tickets that the ith person would like to buy is given. Okay, so for example, if we take this one as our example, here there are 3 persons. The first one is desiring to buy 2 tickets, the second one is desiring to buy 3, and the last one is desiring to buy 2 tickets. Okay, so this is what the tickets array will represent, and each person takes exactly 1 second to buy a ticket. Okay, and a person can only buy 1 ticket at a time and has to go back to the end of the line in order to buy more tickets. Okay, so if let's say we take the example that is given to you, the very first example, there are three people only, so our number of persons is limited to this particular line and this one will not be considered. Okay, so this much portion only. So the first one is wanting to buy 2 tickets, third one is wanting to buy 3, and the second one is wanting to buy 2. Okay, as soon as the first person reaches the ticket counter, he will take 1 second to buy 1 ticket, and if the number of tickets that he want to buy are still greater than 1, then he will go to the end of the line. Okay, you can consider this is the first person going to the end of the line. Okay, instead of n minus 1, you can consider it 1. Okay, so he have to go to the end of the line, and this thing will continue as till when this person gets all the tickets that he desired, the number of tickets. So what you will be given is, first thing, it will be the tickets array that will be given to you. Okay, representing the number of tickets that each person would like to buy. Then another thing that will be given to you is a positive integer k. Okay, k is nothing but the index of the person. Okay, so it is being asked that what will be the total time that will be passed when this k person have done or finished buying his tickets. Okay, so you need to tell what will be the total time required for this person to buy tickets. Okay, so let's see how we can solve this. And before thinking of a solution or an approach, we would like to have a look at the constraints. So the number of persons and the tickets length will be equal, and they will be of order 100 only. and each entry in the tickets array is of order 100 also. Okay, and all the indices or the persons are varying from 0 to n minus 1, and k is also having similar range. So let's see how we can approach this. Here k was given to be, I guess it was 2. Let me quickly check. Yeah, 2. So what the situation is gonna look, these two, these first 0th one and the first one will buy their 1-1 tickets, and they will go to the end of the line. Then the second one will buy his first ticket. Okay, and after buying that ticket, how much time would have passed? It would have 1 plus 1 plus 1. Okay, this is the second person. Okay, now these two will be at the in this particular position. Okay, and then if let's say second person is at the counter, then he will also go behind the line. Okay, and he was desiring only 2 tickets. So you can see that first of all it took him to get his first ticket 3 units of time. Then again it will take him exactly 3 units of time. That's why he is taking total 6 units of time. Okay, I mean this whole cycle will be repeated twice, this 1 plus 1 plus 1. Okay, each person, once he buys the ticket, if he is wanting to buy more, then he will stand at the end of the queue. So this whole circular thing will go on. So that thing is like this. This is the position of the counter, ticket counter, and as soon as the person interacts with it, and he is having more tickets to buy greater than 1, so he will again stand at the very end of the queue. Okay, so this is end of queue, you can say. So this whole circular thing is going on. So very first approach that comes into my mind is try to run a simulation, since the constraints here are pretty low, and n square solution would not give us any kind of TLE or something, because even if we go with n square solution, that would result into 10 raised to power 2 raised to power 10 raised to power raised to power 2 number of operations. So that would be 10 raised to power 4 order of operations. Okay, for n square solution, and there is a limit of for the number of operations that can be done, which is, by the way, 10 raised to power 8 operations. If the number of operations that your solution is requiring to solve the problem is less than 10 raised to power 8 operations, then you are fine, and your solution will be accepted. Okay, so this is the logic. That's why we are first having a look at the constraints and then deciding what kind of solution we can approach with. So this is one way of doing it, and let me quickly copy the code and tell you how we will make this circular queue kind of thing to work out. Okay, circular queue. So without further delay, let's copy that code for approach 1. So this is the code. Anyways, let's explain it here only, or I think it will look nice on board. Okay, let me zoom it a little bit. Okay, now it's fine. So first of all, you will be traversing the whole, you will be continuing this process till the kth person, buys out all the tickets that he is desiring. Okay, and we will be starting from the very first index, which is the 0th index, and we will be going with the entire queue of persons that is given to us. Okay, total n minus 1 people, n people, and we will continue till the kth person is able to buy out all the tickets that he needed. Okay, firstly we will check if the current person that we are visiting, so we will be having an index variable that will act as a pointer to the person that we are visiting. We will ask, are you needing some tickets? Okay, are you needing some tickets, or are you done buying your tickets? Okay, then if he wants to buy some tickets, then we will decrease the number of tickets that he wants to buy. Obviously he will be buying one ticket at a time. So, and then we will be having another variable that is time passed. Okay, as soon as someone buys a ticket, 1 second will be passed, so we will increment this time variable. And this is the whole logic, how we will be approaching a person going to the end of the queue and this circular thing being worked out. Okay, this is person standing in front of queue, and this is person going to the back of the queue if he is wanting more tickets after buying the one ticket that he just did. Okay, he was standing in the front of the counter, he wants to buy some more tickets, that's why he will come at the end of the queue, and this whole thing will continue. So let's take an example of the let's take the previous example. There were 3 people and the indexing was 0, 1 and 2. Let's say you are at the very last index. Then if you want to connect, in order to have a circular kind of thing, what you want to do is you want to somehow connect this 2 with 0. Okay, so as when you will traverse your array in this fashion, you will again end up in a circular kind of thing. So one way of doing it is for example 2 plus 1 will be 3. Okay, which is, by the way, size of the array that is given to us, and this is the last index. So as soon as you take modulo with respect to 3, 2 plus 1's modulo with respect to 3, you will be at the 0th index. So this is a way to implement that circular queue kind of thing. And yeah, that's pretty much it, and this thing will keep continuing till your kth person is able to buy all the tickets that he needed, and at last you will be returning the total time that have been passed. Okay, so this is one way of doing it. Theoretically, time complexity wise, space complexity wise, you would be able to see that we are not using any extra space, so it's constant. And time complexity wise, theoretically we can say that it will be somewhere around, if you take a loose upper bound, so in that case it will be, let's say there are n people. Okay, and n into let's say the maximum number of tickets. Okay, or the number of not maximum number of tickets, I would say it can be equal to k. Okay, so how many times this k thing will be repeating, that many number of times this whole loop will keep continuing. Okay, and this will be and k and n also happens to be of same order, so you can say roughly around, if you take a loose upper bound, order of n square. Okay, so that's why we can take it as a loose upper bound, and you can call it n square time complexity. Okay, so even the n square time complexity will pass, but we can certainly do some optimizations here. Let's see how we can do the optimizations. Okay, so let me first of all copy the optimized code. So let me take it to another slide. I think it should be fine here. Yeah. So in this particular approach, what we are doing is we are just making an observation. Okay, let's say this is the array that is given to you. This is a queue. This is the kth person. Okay, there will be some people, uh, front of the kth person, and some people will be on the back side of the kth person. Okay, so how much contribution can these people make? Okay, each of these persons can make, these people can make individual contributions of, contribution in terms of time being passed, how many tickets they can buy, so that 1 second is being passed. So that will be equivalent to, let me take you to the code, that will be equivalent to minimum of the person that we are talking about. Okay, person other than the kth person, or it can be kth person also. I mean, it will be minimum of the person and the kth person. Why so? Because that loop, simulation loop, was only running for k number of times. Okay, so we were visiting this whole circular thing, which was of size n only k number of times. So that is the only reason in the optimized approach we are considering the persons which are standing before the kth, or at the kth place also. We will be take minimum of the number of tickets that are left for the kth person to buy, and the number of tickets required for the current person to buy. We will take minimum of it, and that will be the contribution of that person to the time. Okay, that will be passed in order for the kth person to buy out all the tickets. Okay, and there is another scenario in which we are considering the persons which are standing behind the kth person. Now there is a little twist here, that when these persons will be visited, or these persons will be at the counter, then this kth person will already have bought its at least one ticket, or one ticket will be bought by kth person before these persons. So we would like to subtract 1 from the number of tickets that kth person would like to buy at this moment. So that's why there is a little change, that tickets that kth person will wanting to buy -1. Okay, because that kth person would already have bought one ticket before giving a chance to the persons standing behind him. So that's why we are taking the contribution of these kind of people who are standing behind the kth person in this manner. And we will continue doing this whole thing and adding the total contribution of the current person to the time passed, and visiting this whole tickets array only once. So this will be a linear time complexity solution. So time complexity wise, it will be order of n only, And space complexity wise, as you must have realized in this one, that we are not using any extra space, so it's constant. Okay, so this is how we can approach it in a different way and reducing the time complexity. Anyways, both are pretty fine. I mean, both will be getting accepted, but this is a more optimized way of doing it. Okay, so this was that we were not trying to run the simulation, we were just making some educated observations, or so in order to reduce the time complexity for that, circular thing is eliminated somehow. Okay, so we are not required to visit the entire array k number of times. Okay, so in other than that, I think this is pretty much it, and these are the two approaches. If you still happens to be having any doubts or any queries in general, then you can ask them in the comment section, and I hope it added some value to your DSO journey. And remember that consistent practice is the only way of mastering DSA. And thank you for watching this problem solving session, and stay tuned for tomorrow's problem. And until then, keep practicing and keep solving problems. See you in the next video.